Okay, so this is all about IO streams, and so what is this IO streams is all about? It's all nothing but input and output streams. We can read the data over the network, just like how data gets transferred, like in bits and bytes. In the same way, when there is a file on a physical directory, and if you have to read something or if you have to write something, then we use these streams to actually write the data or read the data. Okay. So programs need to send or receive information from a variety of sources. File on a disk, data on the network, or data in the memory, or data in another program. So anything that we do is all about data, right? So far we have seen like even classes will have a state that has been stored in terms of variables, and methods are nothing but behavior, like what are all being supported by that, right? So ultimately, when you boil down to creating n number of employee objects, that means each employee object is nothing but a data that we are dealing with, right? Like if you have a table that has like 10 rows in an Excel, say suppose, and each row is an employee data. Okay, so when you construct a list of that file, you will get let's say if you have 10 employee objects, you will populate employee name, employee ID, and employee details and all that in one employee object, and then construct a list, right? In the same way, okay, it's all about data, and that's why we need some IO operations. Like you have a list of file that came from HR, and now you need to upload it to a system, say suppose. You got to read that file, you got to read that data and put it in the system, right? Or somebody has to manually enter it. So either doing it manually, or we are writing a program to read it and put it in the database. Okay, so that's where all these utilities about IO streams and stuff like that comes in. Okay, then what kind of data we are talking about? The data can be just simple strings or characters or images or sound files. Anything is a data. Okay, so the various ways to deal with any of these kind of data is nothing but streams. Like okay, if the application wants to receive or send data, it creates a stream and reads or writes to the stream. That means we write it to an output stream or read it from an input stream. We'll talk about what are the various kinds of streams and stuff like that. Okay, but for now, understand. Okay, so when you want to receive or send, you got to create a stream and read or write to a stream. So that will go. Okay, so that means even if you take system.out.println, what are we trying to do there? System.out is nothing but a print stream, right? Print output stream. So we get a handle of print output stream, and then we are saying like print. Internally, print will handle how to display it, right? So that means we are getting a handle of output stream there, and then we are writing onto the console, right? So in the same way, we got to get a handle of the stream and then read or write from there. That's it. That's when it goes to the destination. Right? Fine. Okay. Let me actually put everything. Okay. So input stream. Input stream is nothing but all these streams handle bytes. Okay. When you talk about stream, that means bytes. Okay. Input stream, it is reading bytes. Output stream, it is writing bytes. Okay. So input stream is nothing but let's go back to Eclipse for a second. I think in our example of this one, exceptions, we created a stream, right? Do you guys remember that in our exceptions programming? I just want to go back to that. Okay. Yeah. So we tried creating something, and it threw an exception. Remember? Okay. So these are all streams that we are trying to create, right? Okay. And when we try to create a stream, what I'm trying to talk about is okay. It has various classes. So input stream is an abstract class. Everything that is being exposed in Java IO API. So anything to do with java.io, like input output is all in java.io package. So if you know java.io package, that means you are able to read and write files, and you have various utilities, how to play around with the buffer and all that stuff. Okay. So main class here is abstract class, which is input stream. Okay. Everything on top of it, like file input stream. If you want to read a file, then we say file input stream, which extends actually an input stream. And if you want to read the input stream in sequence, then we use sequence input stream. And if you want to get the byte array out of the input stream, then we say byte array input stream, like that. So we have various utilities here that has like, okay, if you want to filter on something, okay, you are reading an input stream. If you want to add a filter, like, oh, I don't want to get this stuff, I want to get only this stuff, like that. Okay. Or if you want to piped input stream, like if you want to read only like offsets, like, okay, this is the input stream that I want, and within this offset, I don't want this data. Okay. So those kind of stuff is all about piped input stream. But you can get a question like, oh, which one I will know, like which one to read and which one to write. Depends on the data that, mm, like depends on the data, kind of data that you are dealing with. You will know like whether to use file input stream or filter input stream or object input stream, stuff like that. Okay. So if you just think about it, to me, even like I've been programming in Java like from past 10 years. I've been using file input stream a lot, byte array input stream a lot, and object input stream, like reading and writing objects. But other stuff, even I did not get a chance to use it. That means like use cases are like if you are really on streaming and uh, streaming, or if you are really like write intensive and stuff like that, maybe we use those. But to me, if you are knowledgeable on file input stream, that's why I keep telling you, like not much on interview questions, but you should be able to know it, because that's when it helps you in actually um, in the applications. When you are writing applications, you'll know stuff like if you guys heard about serialization and deserialization, you'll hear it in this lesson, but I'll just give a brief overview. Serialization is nothing but actually you are converting a Java object into a which a Java object implements a serializable interface. Okay, implements a serializable interface, which is a marker interface. That means interfaces which doesn't have any methods. We did not see that so far, right? Interface with no method. So that is called a serializable interface. Okay, so serializable interface, and such a way, if an object implements serializable, um, it it gets like serialization is nothing but in this context is nothing but storing the data. Okay, or it can be on a file, it can be in a database. Okay, or it can be in memory. Okay, so we are implementing serializable in such a way, if an application has more than one JVM, if you deserialize it, that means whatever is in serializable format, if you deserialize it, the data bits and bytes, everything should be matched exactly, and the other JVM should be able to understand as well. Getting my point? Like serializable meaning, okay, on a JVM1, I'm running what is a JVM? Java virtual machine, right? uh, an application like Amazon.com, if you have exposed it as a Java application, enterprise application, it should be always available, right? It can be on n number of nodes and n number of JVMs, right? So on one JVM, you have uploaded your credit card details, say for example, as a file. Okay, as a file. Okay, JVM1 knows it. Fine. Then when some request of yours went to JVM2, when one request of yours went to JVM2, it should not say like, oh, I don't know anything about you. I cannot serve your request. It cannot say that, right? It has to always serve it, right? We think Amazon is all one, right? For as an end user. So though something is being serialized on JVM1, JVM2 should also be able to understand it. Or if you transfer some file, when you transferred a file, it was done through JVM1, and JVM2 also should be able to understand. That means it's all compliant. All JVMs are all compliant to serialization and deserialization. That's what we want, right? So that's why Java exposed some interface implement serializable. So when an object implements serializable, okay, that means serialization and deserialization are all being standard. That means when you deserialize it, also the other JVM will be able to understand it. Okay, so this is nothing but serialization and deserialization. And this serialization and deserialization can happen either over the network when you're transferring data, sending emails, or it can happen when you're by writing an object to the file and reading it from the file, writing to the database and reading from the database, anything. Okay. So all I'm trying to say here is when you're dealing with object input stream and object output stream, that means when you want to support serialization and deserialization at the object level, you will use this object input stream. So that's how I got a chance to use file input stream. Okay, file input stream, byte array input stream, and object input stream. Okay, other stuff even I did not use it, but we will learn in this session. Like if you have to use it, who knows, right? So for interview purposes or job purposes, know like, okay, read a file, write a file, how to play around with it, what is a buffer, what is flush, all these methods, then you're good. Like only so far somebody actually grilled me on object input stream in these many years. That's when I got to learn more about object input stream. Other than that, it's all when somebody talking about stream, it's all bytes. Okay, bits and bytes. When somebody going forward, we'll see some more called reader and writer. That's when somebody is talking about characters. Okay, so when you're actually reading streams, that means it's all byte data in terms of bits and bytes. When somebody is talking about readers and writers, he's talking about all characters. Okay, this is the main distinction that you should be able to know end of this session. Okay, when you want to read stream bytes, you will use a input stream. When you want to write something, you will use output stream. When you want to read characters, you will use readers. When you want to write characters, you will use writers. That's the thing. Okay, this should be the takeaway end of the class. Okay, and depending on the kind of data, you will use byte array input stream or object input stream and stuff like that. Okay, let's move on. Okay, so stream. Okay, it's a bit fancy. Okay, one second. Let this load. Okay, so create a stream. Okay, that means when you're actually writing something here, if you see, if you're writing something here, we are creating a stream. Okay, so add data, Java streams to the stream. On the other end, you can read the characters from the stream, or okay, read character data. That means, see here, even read char. That means actually even the by bits and bytes, like the character data, can also be represented in bytes, right? What is the character byte? How many bytes is one character? Do you guys remember? Do you guys remember how many character? How one character is how many bytes? I'm not. I'm not asking bits. How many bytes? Are you guys with me?
Yeah.
So one character is how many bytes? First
2
session.
byte.
Hmm? What did you say? Yeah, I think
2
you're.
bytes.
Yeah, 2 bytes. Actually, 16 bits we talked about, right? Unicode is 16
Yes.
bit. Yeah. So what we are trying to do is when we created this stream, so okay, we are getting one end of the stream and we are saying like, right, even if you think about system.out, that means we are getting a handle on the stream and we are invoking .println that internally does the write. And that's when we were able to read on the other end, that is like on the console, right? So somebody is writing onto the stream, creating a stream and writing it onto that, and we are able to read it, right? So if you in the same way, if you want to make it transparent, you got to get a handle of like, okay, socket. If you're writing onto a socket or something, you got to get you got to get a handle of it and get the output stream and write on it. Then that's when it is available for somebody else to read. Okay, so that's what is stream. Stream is nothing but collection of bits and bytes. Okay, here input streams are those streams that have a reading end and a writing end, is connected to a source which supplies the data. Okay, so if somebody asks you what a stream is, streams are those streams deal with bits and bytes, reading and writing. And if somebody asks you what is an input stream, input streams are those streams that have a reading end and a writing end, and is connected to a source which supplies the data. Okay, so input stream, it's an abstract class, and it has a why it is an abstract. It's been defined as an abstract, and you cannot create an instance of an abstract class. That's why we say input stream. Input stream equals to new file input stream or something. So one concrete class we actually instantiate. Okay, and it has an abstract method called read. That means whoever is extending this input stream class, they are going to give a new behavior. Like byte array input stream has a read, it deals with the bytes. File input stream has a read method, it reads only the files, stuff like that. Okay, then file input stream. So file input stream extends input stream, and it actually reads either the file as a file object, or file descriptor, like how exactly this file is defined, or just like a string format, like you define the path yourself and it is able to handle it. These are all what are these called? Name of the class, and we are accepting arguments, and I am saying at the end of it we can actually construct a file input stream. What are these called? Getting my question?
Can you repeat the question?
Yeah, so these three in pink, they
Mm.
accept a file object or file descriptor object or a string, and they give us a file input stream object, and within a class with the same exact name as what is the class, and it is giving us a file input stream object. It helps us instantiating it. What are these in a class?
Constructors.
Yeah, so that's why I just want to make sure you guys are paying attention. Okay, so here, these are the various constructors that we have. We can either pass a file object or file descriptor. Let's see how we can construct those as well. Okay, in an example, but think about like, okay, these are the classes that we have. We can construct a file, we can read a file and stuff like that. Okay, let's move on. So input stream, it has a read method. Okay, it has a read method and it is overloaded as well. That means it has a read method with no arguments, read method with byte array, read method with byte array and offset. You can say like from where it can start reading it until how long. Okay, like that. That means you have a byte array of like say 1,000. You can specify like, oh, I want to read from 100 and till like length 100 to 1,000 I want to read. You can specify, or 100 to 900. So you can specify all those, like where exactly you want to read from where. Okay? And void close, like any file input stream or out any streams that you create, you have to close those. Otherwise it will be like a memory leak. Okay, you got to close those. Now with the new try catch with resources, with the one with Java 7, you need not do all that stuff if you put it in a try with resources. But let's talk about that a little later. Yeah. File input stream extends this input stream. This is all we learned, right, just now. And it has a few more methods that it overridden those methods of read and read byte and all that. Okay, and it also has a couple of methods. Available is also been overridden. Yeah. Okay, so no new methods, right, except the giving overridden behavior here. So using a file input stream, so how do you do that? Okay, so you're going to say like, okay, either input stream equals to new file input stream, or you're going to say file input stream FIS equals to new file input stream, depending on the constructor that you're using, right? So if it is a system dependent resource, you're going to give the path of that. Okay, give the path of that. So an input stream is being created, and it gets a handle on the on the hard disk. Say, for example, you said there is a file in the hard disk at some location. You're going to give that location. So JVM through file input stream is establishing a stream onto the hard disk. Getting my point? Like if you write on one end, it gets displayed on the other end. Is it making sense? Okay. So we are reading it if you want to read it, or if you want to write, you are going to write on the other end. Okay. So if you write onto the file, you will be able to read it using file input stream. So FIS is the handle to the stream. So one can only read from this stream. Okay. Input stream is for what? For reading, I said, right? So if you write onto the file, you will be able to read onto this. JVM can read that on the other end using the file input stream. So file input stream is establishing a stream to read data from the hard disk or wherever stream, like however you constructed your stream, either on a file or directory and stuff like that. Okay, FIS.read will only read from the file in the hard disk. Okay, if you have provided a file. See, that's how it goes. Then, reading through streams. So open a stream, while more information, read information, and close the stream. So this is a sequence. Okay, you are going to open a stream. You're going to say, you got the stream, right? After that, you're going to open it. And you're going to read the information from the stream, like content on the file, and close the stream. Okay. So let's see an example. Read from a file given a string in the command line and then display the contents on the console. That's the task, right? Read from a file, give the name of the file from the command line. That means arguments on our program, right? Args. If you pass an argument to the program, that's nothing but passing it, and display the contents of the on the console. Let's see file input demo. What it is referring to us. Okay. Okay. Just a second. I'm just copying this over. So these are a bunch of examples, but we may not be able to see all the stuff. But feel free to take a look and let me know if you have any questions. Okay. Okay. Let's see. So the example that we want to see is this guy, right? File input demo. Let's see what it has to show us. File input demo. Okay. Okay. So one of you have to explain me this Java code. Who's going to take the turn today? Okay. Like from where the execution starts, what exactly is happening. Forget about IO streams. We are dealing with objects and classes, right? So I want one of you to volunteer and explain the program. Like we are now at a stage, we should be able to read the code. Okay, at least reading the code is my must by now. So who wants to take the turn? Brinda, you want to try?
Just checking the code, I think.
Yeah, yeah. And give it a try. I'm here to help you out. So that's when you'll lose your fear if you're afraid of programming. So in a class where exactly the execution starts?
Main method.
Yeah. So bring the take the initiative. Come on. So start from line 12. Okay. Talk about it now. Are you here?
Yeah.
Yeah. Go ahead. Go step by step. That's okay. Like even if you did not get it, that's okay. We can talk about it. That's when you can talk about it next time, right? So where
No,
exactly you're
it's
looking
okay,
at?
Ravi.
Huh?
No, it's okay.
Yeah.
Someone can take it.
Someone can take it.
Yeah,
Then you
someone
cannot
can.
try it any other time. Then I must say that. But those are not loops at all. That we know already, right?
Yes.
So, to make sure everybody is on the same same page, okay. So if you are not passing any arguments, that means no file you have given, then it will not execute. It says invalid parameter, okay, which is good. Then, as you said, if I give more than one parameter, what happens?
Then also it goes to the else block.
Yeah. So that means what we are trying to say here, we are accepting only one parameter here, right? That's when it gets
Yes.
executed. Fine. You gave one parameter and you tried instantiating a file input stream. Okay, so that means what? You're opening the file that is the first parameter from the command line argument, and you're constructing a stream. Okay, fine.
Okay.
So once you converted a stream, what this guy is talking about, he wants it to be a data input stream. That means forget about this for a second. Even before that, even just with file input stream, you can read the data. But why are we using data input stream here? Let's see. A data input stream lets an application read primitive data, Java data types, from an underlying input stream in a machine independent way. An application uses a data in output stream to write the data that can later be read by a data input stream. That means is not necessarily safe for multi-threaded. Thread safety is an optional thing. So what we are trying to do here, we are actually trying to convert these to a data input stream. That means if you want to write it back onto the console, okay, here what we are trying to do, we are writing back to the console. By definition, what data input stream does, it actually reads the data and again converts it in such a way it can be used by any other output stream, right? So what we are trying to do here, print output stream, and we are passing this, right? It's all deprecated methods. See, read line. We are using a read line method. Instead, we could have used just the read method. Okay. Okay, read method. Fine. We are using a deprecated method which may lose support later, but all we want to do is line by line, we just want to spill it out, whatever we read. Okay. So because we are actually putting it onto another output stream, we are using a data input stream here. Otherwise, we could have just continued with our file input stream. Okay. Generally, we use either data input stream or buffered input stream or byte array input stream on top of file input stream. So that way, if any other stream needs to handle it, like writing it onto it or writing onto a different file or writing onto a socket or something like that, we use all this byte array input stream on top of our data input stream on top of file input stream. Okay, so what we are trying to do here, line by line, go ahead, like now talk about it, like you were in try, right? Continue.
We are creating the file input stream from
Mhm.
the given file name.
Yeah, what happens when you gave
Um,
invalid file name? So you have given a file name and that file name does not exist. What's going to happen?
it's going to end in the catch block.
Catch block, right? So that's when it says like file input error,
Yes.
right? So any exception
Yes.
that happens here, we are taking care of it, right?
Yes.
Yeah. If I have this, what's going to happen? If I have this,
Uh, After executing catch, it will execute the statement and finally.
yeah. What if catch did not happen?
Then also the statements and finally will execute.
Yeah, that's right. So why am maybe you guys think it's all repeating, but all those concepts will that we discussed in exceptions keep happening in our going forward classes. That's the thing I want to demo. Like this is a simple example, but I'm asking somebody to actually go through step by step, is because that helps you making it readable, right? You can read the code and understand what it is doing, why it is doing, and all that. Okay. Okay. So now you got the file input stream, and on line 22, what are we trying to do? We're actually
Uh,
converting our input stream to a data input stream, right?
yes.
Yeah. So we got this, and what are we trying to do here? Until the data is available within it, we keep reading the data. Reading. We put it in a while loop, right? So that means we are
Yes.
looping it until the data is available, until the end of the input stream, right? Until the end of our data input stream, we're actually going down and spilling out onto the console. Okay, so we are done with that loop, and then what we are trying to do, we are using a close, in dot close. That means we are actually closing the input stream, right? But
Yeah.
there is a flaw here. Okay, you are creating an input stream and you are closing it. What if one of these, if an exception happens here, right? If an exception happens here, in remains open, right? We should not be leaving anything open like that. We should be putting these kind of close and all those stuff in finally. That's when, whether an exception happens or not, this close always gets executed. You see what I'm saying?
Yes.
Yeah. So all these problems are with our traditional approach. Or if you want to actually use the new approach, what are we going to do? Probably this project is created with 1.6, but how did we come around with that? We actually use a try with resources, right? So try with final input stream and then followed by this one. So once an exception is thrown or something, also or not, that will take care of closing the stream. That's the advantage. Okay, try with resources advantage is that. Okay, so let's try executing this guy and see if I have any file that we want to read. Okay, do I already have an argument within this? Let's see. I don't have an argument. Okay, so are you guys following so far? Or any confusion?
Uh, why can't we use the file input stream? Why we are creating data input stream?
Yeah, that's what I told you, right? Like if you want to spill it out here onto another output stream, this is another output stream, right? So if you
Yes.
want to manipulate data and put it onto another output stream, this makes it friendly onto the other output stream.
Okay.
Yeah. So let me actually create a file. Okay. So let's see. Ah, it's executing the other one. Why is it executing the other one? Yeah. Okay. What is it called? File tested. Okay. In finally. So that means what? It's not able to find my file, right? See here, in finally, directly it is going here, an invalid file input error. Oh, that means it's throwing an error here, right? Input file, the file I'm passing as input, it says incorrect. Let's see why. Okay, so it got users file test demo. Do you guys know what is going wrong here? What's going wrong here? Can you guys figure out? Do you see the debug thing that I'm focusing on?
Yes.
Yeah, I did not give the .txt. That's the
Mm.
problem, right?
Yeah.
Yeah, let's see. Yeah, now it did not throw an error. Okay, so now it's spilling it out, right? Okay, as you said, let's see. So this is ours is a simple one, right? So what we could have done is we could have just put it like this. So you cannot control it like line by line and stuff like that if it is file input stream. You see what I'm saying?
Okay.
Yeah. So we could not control it line by line. Uh, we could just say read. Okay. We could just say read. Let's see what it is going to show us. So those are giving us more utility methods to justify what we discussed. Those gives us more utility methods and more handle on the byte, the stream that you got. Whereas file input stream doesn't give us those. Okay. So if you say file input stream dot read, let's see what it is going to show. See, it's showing some byte number. I don't know what it is actually. Let's see what it is. When we say read, yeah, reads a byte of data
1392.
from this input stream. Yeah, it's going to give us next bytes that are available or -1 if the end of the file is reached. So length of the characters probably. Let's see what else I can use in from here. Notify, wait. These are like standard methods, right?
Mm.
You got the stream out of it. Yeah, there are not much in here that can actually bring in the data that you have. I can just think about only this guy, but this is going to give us the object ID, I'm pretty sure. Let's see. Yeah, object ID. So there are not much of utility methods if you just try using that. It just gives us the channel stream, and you can use on top of it constructing a byte array stream or data input stream and stuff like that, and you can get a pretty good handle on all your output data, like line by line or however you want to read. That answers your question.
Yes.
Yeah. Okay, fine. So let's move on. So this is how we could read data from a file, right? Let's move on. So output stream. Now we saw all about input stream, and we are just discussing about output stream. So file output stream extends output stream and filter output stream. So wherever you saw input, you will have an output corresponding to that, right? So that's again an abstract class, and all other classes are like concrete classes that are implementing those abstract class. Okay. So you have a write method. There we had a read method, right? Now here you have a write method. And file output stream that has like a bunch of like where exactly you want to create a file. Previously, where exactly you read from a file. You read, right, on the hard disk. That is the path you're going to give. Now, instead of that, you're going to give the path of where you want to write a new file. Okay. Then what is happening here? It's reading from this end and writing onto this end. So when you write it, this is where it is being read. Okay. Whereas in read input stream, you write on a file here, we were able to read it here. So JVM through this channel, through this stream, can write here, and it can it can be read from here on the actual file. Okay. So fis.write will only write to the file in the hard disk. Okay. Open a stream, while more information, do something whatever you want. Write while more information is available, and then close the stream. Okay. So we'll see read from the console and write it to a file. Okay. Given as string in the command line. Okay. Let's see. So if you read something from and you want to write it onto a file. Okay. Let's see the file output demo. Okay. See, I'm trying to write myfile.txt. I did not give any path, right? When I don't give any path, it's going to create it somewhere in this project. Okay. Wherever my class is executing, that path it takes, it assumes, and it creates a file there. Okay. So what I'm trying to do, okay, I need to create a file here. So I got a handle of that file, and I created a print stream of that file, and I'm using p.println. We know println method is there, right? Similar to system.out is what? Print stream. Println. So this is written to the file. Okay. So we are actually writing it onto the file. Okay. So what are we trying to do? We're getting the hold of an output stream. And again, similar to input stream, output stream has not bunch of stuff to do. We can either use a data output stream or buffered output stream and get a handle of it, right? So in the same way, if you want to write one line, like this is written to a file, you can just get a handle of the print output stream, which is constructed on top of this output file output stream, and you're writing. Okay. So file input stream and file output stream are just like a one step to either create a file or read from a file. Okay, rest all reading and playing around with data, we need to depend on somebody else, like data input stream or data output stream or buffered input stream or buffered array output stream and all that stuff to play around with data, write line by line, and all that. Okay, so let's execute this. Okay, nothing gets displayed on the console. Okay, but something to be written onto the file, right? Let's see. See, it created it here. Okay, this is written to a file. Okay. So it created a myfile.txt, and this is what it could write like this, because this is the string that we are writing on. Say, just like system.out.println, did you follow the same? Like what we are trying to do, we are getting the output stream and we are using println method to write it onto it, and we are closing it again. This is one way of doing it. I'm not saying it is a standard way of doing it. This is how you get an output stream, and on the output stream you just control it. And similar to what you got a question before, you may say, why can't I just say out.write, right? Okay, can use it probably. Let's see, but not much control there. You need to put in bytes here. If you see, you need to put a byte array, right? How are you going to get a byte
Yes.
array?
Great.
Yeah, here you can do that like this. That's what I'm hoping. Like this dot. This is string, right? String can be converted into bytes. String dot. What is the method? Get bytes, I think. Yeah, get byte array. Okay. So byte and out dot close. Let's see how it is going to behave. Okay. I think it should work, but let's see. Okay, it did not throw any error because we did not say it here. Let's see. This is a file, right? Yeah, let's delete the file. So that's when we'll know more. Let's also put a debug pointer here just to make sure. Yeah, it wrote it. But we cannot do much. How many times you can invoke the get bytes and stuff like that? So that's the thing, right? Any questions? Are you guys with me?
Yes.
Okay. Others?
Yes.
Yeah. Okay. Cool. Let's move on. Okay. So now we saw streams, how to read a file and how to write a file and stuff like that. Let's move on. Okay, class file. So uses of file class. Okay, class file. This is not a class file. It is a file class. Actually, I will change it. Okay, to extract information about files and directories of the local file system, and construct an object and use its methods to obtain information about the file. Okay, so there is a file class itself. Okay, and that has various utility methods to know where it is located and which directory it is located, list all the subdirectories within that and stuff like that. So we can take a look at that. So how can you construct a file object? By giving the path similar to file input stream. If you give the path, it is going to give us a file object. Okay, and you can get the absolute path, canonical path, like a fully qualified path and all that stuff, or just the directory where it is in, and is it read only, or when it has been last been modified, and if you want to delete it. All these are handled in file class. Okay, so use java.util.date to convert into the date format, desired date format that you want. Okay, so write an application in Java to display list of directories or file contents of the specified file path. Text field should be present at the top, in which we can specify the file path. That's okay. You need not do a text field, but what we can do is write an application in Java to display, like given a file directory, it should display the directories, list of directories, and within directories, if there are files, it has to display the names of those files. Okay, so this can be taken as an assignment, and if you want to, if this is the question, file test.java, let's see what it does. So I heard Rini, right? Rini, are you here? Okay, yeah, same. I didn't want to confuse you guys before doing the action listener stuff. This is all AWT, but this being aside, I'm going to change this class. Okay, here I'm just going to make it simple for you guys. So I created a file test. I read a file, name of the file. We are going to give it as argument here, right? Name of the file, we're going to give it as an argument and say like, okay, if the name exists, like if file exists, what we want to know, whether it's a file or a directory, or right, all that stuff we want to know. So let's say string txt text equals to, let's remove all that stuff that we don't want yet. Okay, so you got to know like, okay, what kind of text. Okay, whether it's if it is a direct file, we are going to ask, oh, is a file, or name, is it a directory? Yeah, is a directory. Absolute path, or last modified date, length, path, absolute path. So again, they put it again, I think here, absolute path. Okay, and then parent, who is the parent of it. And then if it is a file, we're reading a file. Random access file is actually a class. Yeah, it's a class. And what does it do? It has a bunch of stuff, like instances of this class support both reading and writing to a random access file. A random access file behaves like a large array of bytes stored in the file system. So that helps us getting the pointer out of it, like a large array meaning it has like various indices, right? So you can write it at index 10 or index 20. So it gives us the flexibility to write it wherever you want. That's why it is called random access file. Okay, so you can access the file at various pointers, okay, at various indices, and that makes it so flexible. Like wherever you want to get, you can get the cursor out of it and start writing from there. Okay, this is one interview question. When I started, people used to ask a lot. Now I don't hear much about random access file, people asking about it. Yeah. Yeah, I'm just modifying this without compilation errors. String text, I can just say string text one. Then what does this do? It's appending an output, right? Okay, new line, new line, new line. So let me put it as a string buffer, so we're good. Okay. Okay, so we know everything in here, and we know this guy. Yeah. That's okay. We can just say sysop here. Okay. So what are we trying to do here? Who wants to explain it now? I need turns, otherwise I'm not really following whether you guys are here or following the class. Similar stuff, right? What we are trying to do here is all same. Every class is like has the same structure and all that, right? Who wants to explain it here? Other than Teja, who wants to explain it? Yes, she tried already. I'm not partial there. Rini, are you here? Soumya, you want to try? Okay. So what are we doing here? We have a class OOS point, right? We are creating an object output stream. We have a vector here, right? Vector, and we have a bunch of objects within a vector, right? What are we trying to do with those? We are adding points in between points in a vector. So we added some strings to the vector, some objects to the vector called point. That's okay. Then what we are doing, object output stream, and we said, okay, where do you want to put the object output stream? Onto a temp data, right? And then we're writing an object here, right? So we wrote that object and it's an temp data. And what is the name of the object? Name. Name has what? Name has this point P and P1. And that P and P1 resemble anything? Nothing, right? P and P1 doesn't resemble anything. But we also wrote another object, string, in middle of vectors in file. So that means we added two vectors, right? This is one vector and this is another vector, and in between we put a string, right? Let's see. Once we are reading it, what are we trying to do? We're reading the temp data as an input stream, right? So we read it and we read it as an input stream, and we are saying read object, okay? So what happened, ios.read object, and we typecasted it to vector. It gave us the vector, see here. And ios.read object, we said typecasted it to string. It gave us a string. ios.read object, we again typecasted it to vector. It gave us the vector. Okay. So read name gave us the elements within the vector, and the string that we wanted. And there's another vector. See how sequentially it's saved, and how flexible it is. When you said read object first, it gave us the first one that is being persisted. We know we persisted one vector first, right? And then we read a second one, and then we read another third one. Okay. If you give me an opportunity, I would have put all these three in one object, and I would have put like write object. You see what I'm saying? Like this vector and this vector and this string, I would have put it in one class as a bean, like all these three properties, and I would have put only one overs.write object. So when I say overs.read object, I would have got all the values, and I would have just uh, I need not do this sequential steps then, right? I could reduce that to one step if I set all these three properties to one object, right? Name and n, and the in between string. If you put this to employee object, say suppose, I could have said like os.write object employee, right? Making sense? Are you guys with me?
Yes.
Yeah. Okay. So this is something about object output stream. Then serializing custom classes. Okay. So an object written by a programmer becomes serializable by implementing a serializable interface, which is a marker interface. Okay. Remember that. Give me examples of marker interface. Serializable. Okay. Serializable is a marker interface because if you look at it in Java APIs, do you see a serializable interface here? No, right? Hmm. Okay. Serializable interface doesn't have any methods. Generally, generally we see there are methods, right, for these marker interfaces. So serializability of a class is enabled and all that stuff. Let's see if they talked about anything on marker here. No. So it doesn't have any methods. If you look at it like this, if I say serializable, go inside serializable, there are no methods. Okay. So that's why it is called marker interface. Okay. See, there are no methods inside this. This is one other example of marker interface. But this have methods, write external and read external. Do you see that? So this is not an example of marker interface. Okay. Any interface that has no methods, those are called marker interfaces. Examples of those are serializable and clonable. I used to say externalizable also before, but after I explored it like this, I've never say externalizable is an interface example of marker interface. Okay. So Remember, when somebody asks you what are the various examples of market interface, you could say serializable and externalizable. Okay, fine. An object, like if I am writing an object, employee object, becomes serializable by implementing a serializable interface. Okay, and serialization is then taken care of by default write object method of the object output stream class. And deserialization is similar to be taken care by default read object of the class. So JVM internally implements those for us. Okay. Then serializing custom classes. This is where we were, right? If you want to add additional information to the stream, then one has to override the write object method in their class with signature like this. Provide private void write object method. So you will need to call the default write object method to serialize the data of your class. And after that you can add whatever data you want to serialize along with the class. So if you want to like whatever information needs to be serializable, you have to put it by overwriting it in the write object method. Okay, so you have to custom write it serialization for if you don't want everything to be written. In such cases they will have to read the data in the same reverse order and override the read object method in their class. So this is what we were talking about and examples of it. So file channel, a file channel for reading, writing, mapping, and manipulating a file. A channel for reading, writing, mapping, and manipulating a file is called a file channel. This slide concentrates on file locking mechanisms. Like I was talking about file locking, right? So what does it? Like file channel lock acquires an exclusive lock on this channel of the file. File channel lock like position and how long, like what is the size of the file and is it shared or not. We mention it while defining the lock, like so people can share the locks. So why do we need a lock? Because when more than one process is trying to write or more than one thread trying to access the same file and trying to write it, always we want somebody like we need to have both the saves, right? If I save the data and you save the data, I want both to be there. I don't want it to be lost, or I always want to see the latest version of the data, right, before modifying it. So that way we don't lose any updates, right? Like I modify something, you modify something, uh, and you are removing some block which I am editing, it may be lost later, right? So that's why I didn't want that to happen, and that's why we introduced something called locks. So that lets us putting a lock on a file. Okay. So the above methods return a file lock object. Like when we say file channel.lock or file channel.lock giving some arguments, it gives us a file lock object. And if you want to release a lock, you will say file lock.release. Yeah. So let's see this file lock demo. Okay. So what are we trying to do here? We read the argument, command line argument, and where are we using that command line argument? We are not using it anywhere, right? And then if we would have said like this, then we are using it, right? Okay. So we are reading the file input stream and we are getting the channel out of the file input stream and we are locking it. Okay. And we are like waiting like 3000 times, like thread dot sleep. We are going to talk about it in threads, but this actually makes for sure this object is going to be like waiting. Okay. Until this sleep time is expired, like 3000 milliseconds. Okay. 3000 milliseconds is expired. Until then we keep waiting on it, and it is guaranteed that after 3000 milliseconds thread is going to be executing. Okay. So then we continue that, and then we release the lock. That means we have the lock for 3000 times 10 definitely with us. That's what we are trying to do here. Okay. So open the file, that is first, and we got the lock of it. Okay, and then you're releasing the lock. So so you are achieving a lock, like demonstrate the file lock. Let's see here. So that's how you're going to lock a file, uh, and you own the lock. When you own the lock, you can actually write it onto it and save it. Nobody else can write it. Let's see probably if I can demonstrate that or not. Right, so let me see here. This is file demo, right? Let me see if I can actually, while it is sleeping in there in that thread, when that thread is sleeping in there, will I be able to do any edit and show you guys a demo or not? Let me see, it's interesting. What is it? File test demo, right? Let's see here. File log demo. Okay, okay, so we got the stream, we logged it. What is happening here? It says it did not say the cause. What did it say here? A detail message. So it's not letting us create a lock. See here, it's not letting us create a lock. Why? Because I'm thinking the reason being I have this open here like this. I'm thinking this is the reason, but let's see. I closed it now. Okay, let's see if we will be able to attain a lock. Still the same. Okay, is it a read-only file? Do I have it open anywhere else? File test demo. I don't have it open here. Okay. So when does this lock throw an exception? Acquires an exclusive lock on this channel. An invocation of this method of lock behaves it exactly like the same way as invocation of this. A lock object represents a newly acquired lock. Okay. Non-writable channel exception. If this channel was not opened for writing, okay. If this channel was not open for writing, then we may get this exception, is what they are saying. Like that means I only have a read-only access to that file, right? Let's see. How can I make sure I have write access as well, right? Okay. So look at the file. That I am interested in is, so let's see now again the file. You see file test demo. So now it is RWX. So looks like all permissions are there now. Let's see. It's just a Mac thing. Probably you guys can do it pretty easily on Windows. Still the same. Okay, let's put something like test.txt. It should not work, right? If I say text.txt. Yeah, because that does not exist at all. Yeah. Okay. So what I'm going to do is, let's see this. Yeah, see. Now it let us do the lock. That means when we say fchannel.lock, it is actually trying to put a write lock. We don't want a write lock, right? Previously we were actually just reading it. When we are reading it, we cannot write onto it. When you're opening it for output stream, that's when you're able to write onto it, right? So that's what is called this one lock. So now that you have a lock object, okay, now I have a lock object, and it must have created a file. Let's see. Okay, I'll show a demonstration a little bit. Let it create the file. Let it execute, or I'll terminate it. So I terminated it, and now what I want to do is, I want to give an absolute path here, right? I'm going to create a new file called txt. Okay, let it run through. Okay, let it run through. Do we have a file called text.txt now? Yeah, we do. So let me open that guy. Okay. So what I'm trying to do now is, so we attain the lock. Now we have the right lock. I'm trying to modify it. Save. Let's see what it is going to do. Let the execution finish. Like it's going to be like how many? 30,000 milliseconds, right? Let's see what it has to do for us. Did not do much, right? I think operating system did not honor, like whatever I did was being honored. Though there is a lock in here, though there is a right lock in here. What I want to show is if I am editing it from outside, um, yeah, if I'm editing from outside, nobody should be able to execute anything, right? Let's see. A token representing a lock on a region of a file. So a file lock object is created each time a lock is acquired on a file via the lock method. But a file lock object is initially valid. It remains valid until the lock is released. So yeah, that's the thing I want to show. Like if I do it from outside, it should throw an error, but I don't think I can demonstrate that because OS does not honor it, because OS does not know there is a lock on that file. Only through two Java processes probably. If I have, let's see here. Mm, I have one lock here. We can talk about it in threads probably. I don't want to confuse you guys. All we know here is we can attain a lock when you are writing a file. Okay. All we know is when you're writing a file, okay, when you're writing a file, you can attain a lock. So it will be agnostic to the changes that are done to the file by other processes. Okay, by other process. Let me actually print out something in here and let's see if that sticks, right? Okay, let's see what it is going to do. It's going to execute like for 30,000 milliseconds. That's how much? 30 seconds. Should not take more than 30 seconds. Probably 803. We should be able to see it has been done execution, right? Close to 803. What's the time now? Right, it should not be. Yeah, that's right. So it's done execution, and let's see what it is doing here. Okay, so it's refreshing that. So when it is holding the lock, all I want to show you guys is when it is holding the lock, yeah, when it is holding the lock, now it has the lock, right? It will not throw error. It will not throw error, but it is agnostic to changes done by other processes. See here, other processes. This is a process that I have, and I have written something to this file. Okay, I have written something to this file for a bunch of times, right? Um, but it's true. You can say it is true even if I just open it outside and without having a lock. Also, I can actually um, without having a lock. Also, the behavior will be same. Yeah, I will not be able to demonstrate that probably. Um, it's only between two threads. Okay, what we are looking at is between two processes. Okay, see here. So what it did, it is done execution. It is done execution, and it did. Okay, I have written this outside the process, and it just cleared. It just put this one, right? So what is happening here? When we are putting in a lock, okay, let me also demonstrate something else. I will not put lock here. Okay, I'll not put a lock in here. Okay, um, let's just comment this guy also off. No sleep. Um, just that I don't have a lock here. I'm just writing whatever is there, right? I'm just writing whatever is there. I don't want a channel as well. Um, Before that, I just want to put 10 times. No, I'll just remove everything off. Okay, I'll just remove everything off, and I'll put a breakpoint in here. Okay, right. When it is waiting, I'll write something there. Let's see what is going to happen then. So before the stream has been closed, I put something in here. Okay, we saved. Okay, so no change in the behavior, right? Yeah. So whether we have a lock or not, okay, what I'm going to do is before even, so let's go back in here. Okay, so I got a file output stream. So I got a handle of the file. At this point of time, I'm going to write something in here. I got a handle on the file, and then I'm putting in this. So yeah, it's just, yeah, it doesn't do anything different whether you have a lock or not. But there should be flush or something. Flush is to spill it out. Flushes this output stream, forces any buffered output bytes to be written out. So this doesn't help. Um, this doesn't help. All I'm trying to do is, okay, let's remove this stuff altogether and execute it one more time. All I want to do is when you are locking it, it should not honor any other changes to that file, if that is true or not. Okay, that's what I'm trying to validate. Okay, and just pass it through. Yeah, so previous ones are gone, right? So that means when you are getting a file output stream handle itself, it is flushing it. Okay, but once you attain a lock on the stream, afterwards it's not just the only process that is writing. You see what I'm arriving at? Let's go read the definition of file lock one more time. Here, file lock is there, right? Do you guys see file lock object in here? It's not file lock exactly, is it? It's part of, okay, channels, NIO channels, okay. NIO channels, okay. And in here, NIO channels, why it's taking a lot of time to load? File lock. Are you guys with me? Like, are you guys trying to understand where I'm trying to arrive at? Like, file lock, a token representing a lock on a region of a file. A file lock object is created each time a lock is acquired on a file via one of the lock or try lock methods. Okay, so a file lock object is initially valid. It remains valid until the lock is released. Good. But what should happen? A file lock is either exclusive or shared. Okay, maybe the file lock that it is creating is a shared lock. That's why I was also able to edit it. Okay. Um, so a shared lock prevents other concurrent running programs from acquiring an overlapping exclusive lock, but does allow them to acquire overlapping shared locks. Okay. An exclusive lock prevents other programs from acquiring an overlapping lock of either type. Once it is released, okay. So we want to get a shared lock, and we don't want to get a shared lock. Okay. So let's see whether each shared is returning true or not. Okay. Let's see here. Go back to the same thing. Okay, we got the lock, and let's see. Before doing anything, actually, let's print out we don't wait also, right? Add block is shared. Is shared. If it returns false, then I don't know how to demonstrate, but let's see. Is shared is false, it said. Ha. So it's not a shared lock. That means, okay, why it is throwing an exception? Oh, closed channel. Which channel is closed here? Oh, because I'm doing a stream lock and POS lock. Let's see. Let me execute it one more time. Sorry. Yeah, no, it did not throw that error. I was thinking what I'm trying to do is, okay, it said it is not a shared lock. Okay. So whether a lock is exclusive or shared may be determined by the is shared method and tells whether lock is shared. True if lock is shared, false if it is exclusive. And if it is an exclusive lock, maybe programmatically it will not allow, but what I am trying to do is totally a different way, right? Operating system. So probably operating system way is given more preference. If I try to do another program, another file output stream, and try to edit the same file, probably that's when it is going to complain. You see why I'm trying to what I'm trying to do here. Okay, let me actually do one more step here. Like I'm going to create another file output stream, right, of the same file, and this guy has a lock already by then. And what I'm trying to do is do the print output stream itself, right? Do the print output stream itself, and cannot attain the lock. Okay, cannot attain the lock. POS1. Okay, this is all with one. What I'm trying to do is all with one, and fstream1 dot close. Okay, so that means somebody else has a lock, and I am trying to write to the channel before a lock is being released. Okay, let's see if this goes through actually, right? Let's see what this is going to say. Okay, here we got the files output stream, we got the channel, we attained the lock here on the channel. And again I'm reading, and maybe think of it like a different thread, and this channel is actually locked, but I'm trying to write, it did not say anything. So let's see, by then it did it put, yeah, it put the cannot attain lock, and it is not a shared lock, it said, right? Yeah, yeah. Though it is locked, it is actually writing both. I expect it to not to write both. I expect it not to write both. Hmm, how else I can do it? Right? Maybe I have to put a different thread. It's the same thread, right? So this thread owns it already. So that's why maybe. All I need to, okay, I'll create another thread probably. That's when it may throw errors. There's one last test. Let's see. All I'm trying to show is when one process locks it, other process should, one thread locks it, other thread should not be able to write to that. Okay, that's what I'm trying to demonstrate. Let's see here. Actually, I can do it in a threads class as well, not to confuse you guys. Okay. Uh, I'm just curious. That's why one last attempt I'll make, and I'll go forward with this. Okay, so what I'm trying to do is, so when one thread executes, it is locked like this, right? It's locked. Okay, get the channel out of it. Yeah, so it is locked, and once it is locked, I'm trying to, okay, attain the lock, right? Get a lock of it, and I want to release the lock just before closing it. Okay, so release the lock. So when a particular thread executes, I'm locking it and releasing it. Let's see now what's going to happen, right? Um, so all I'm trying to do is, okay, let's go back in here. I think I'll start with a little bit on threads, and then I'll create a thread here. Okay, so we're done with IO streams. All I'm trying to do is concurrency. But before that, before I let you guys go, I will show how to create threads. So that is what I'm trying to do right now. Anyways, I'll just do that while you guys are around. Okay, here, threads. Okay. Right. So, so this is what I'm trying to do. I'll explain it in a bit, but this is what I'm trying to do actually. Okay. So I'm going to do this one. Okay. So I'm going to say thread1 and t1 dot start. Okay. And then I'm also going to create another thread. I'll let it sleep for a few minutes, few seconds. I don't want to sleep, let it sleep. Okay. Start another thread, t2 and t2 dot start. Okay. So all I'm trying to do is two people, two threads trying to access it exactly at the same time. This method and try to modify it. Okay. And I would let this sleep after a bit. Okay. So that way we are introducing some delay. Okay. So okay, I put 30,000 like before. Okay. Let's see what's going to happen in this. So I'm trying to do two people trying to execute it. I should have put this one here. Okay, it may be the second one already. Yeah, see here. Overlap file lock exception. Okay, so that means when somebody like the first guy is trying to write, the second one cannot write. Okay, so maybe first thread must have succeeded. Actually, this is what I want to demonstrate. Let's go here. Okay, first one, the T1 start. Okay, so if you go here, so that means thread execution started and it went in here. So we know nobody else entered here and it is sleeping right in here. If you go here back onto the main thread, the second thread started, and when second thread started, you come back in here. So it is trying to attain the lock, and we are saying like, oh no, somebody else is already executing it, and I will not let you write it. This is where I ended up. Like, this is what I want to show. When somebody is trying to write, and if you have a lock, it will not let other person write it. But previously I was trying to show you guys on through OS. Yeah, OS, it's all native, right? So Java JVM cannot control that, but this can be controlled through like okay, if your Java program is writing onto a file, nobody else is writing onto it. Like it makes sure only one person who has a lock will be able to write it. Did you guys follow like what we went through from past half hour? Is it making any sense to you guys? Are you guys here?
Yes.
So did you follow? Like, what was the thing that I am trying to demonstrate actually?
Yeah, when we acquire a log, you should not write. You should not access.
Yeah,
I
the
mean,
thing is,
you should
it's
not
not a
modify.
shared lock. It is a mutually exclusive lock, right? So we're not letting anybody else to write, right? So that's why it is actually throwing that error. If it is not a shared lock, then it would have let the other thread also go through. Any questions?
If there
Uh,
is a shared log, we can the other
yeah,
thread
yeah.
can
Let's
access
see
it,
how to create
right?
a shared lock. Yeah. I just gave randomly 0 and 1,000. I don't know. Okay. 0 I know because that's where it starts. But yeah, let's see whether it's a shared lock or not. So here, yeah, shared is true. Let's try executing this now. So one thread started executing, and we know this thread can attain the lock, right? So there is an error here. What does it say? Non-readable channel exception. That means we got the channel, Oh, it's this exception is at the channel level, or where did we get this exception? Let me go back. Oh, we got it at the lock because I put 0 and 1000 probably. So what do I need to put as a sample? Zero argument method lock simply locks a region of okay. What do I need to put? Position. The position at which the lock region is to start must be non-negative. So I gave 0. Size of the locked region must be non-negative. Sum of position plus size must be non-negative as well. Okay. So let me see how to put that right. Okay. Mm, let's see the lock method itself, right? We can put the same values. Even that should also call the same, right? I'll put the same. Okay. Let me also close this guy. Okay. Okay. Still throwing the same error. Non-readable channel. Why? Class not loaded. Type has been loaded occurred while retrieving the component array. Non-readable channel. Okay, let's see when it will throw non-readable channel exception. Even for both. Is it for both? Yeah, both are throwing the same error to get the shared lock. So let's see when it will throw non-readable channel exception here. If shared is true, this channel was not opened for reading. Okay, we opened this for writing only, right? See here, we opened it only for writing. It should be open for reading as well. This channel should be open for reading. Let's see, what is this? Mm, okay, so it's non-readable. If shared is true, this channel was not open for reading. Okay. Okay, so this channel was not open for reading. How do I make it open for reading? Can I set something in here? I cannot do anything here. I cannot do any setting here to make it read, right? Okay, because this is from this one. Okay, so shared logs can be acquired only on readable channels. On readable channels, not on the writable channels. That's the conclusion here. Okay. So if you are trying to write, we cannot do this. Probably all we can do is this one. To your question, we can do a try lock. Okay. We can just do a try lock and maybe let's see what it will throw. Try lock method attempts to acquire a lock. It will not throw that overlap exception. So if a lock that overlaps the request region is already held by this Java virtual machine, or if another thread is already blocked in this method and it is attempting to lock an overlapping region of the file. So, okay, overlapping file lock exception can still happen, but we can specify how long it can try. How long it can try, we can specify. Probably one more argument. Let's see if there is any other method. Okay, let's see if it still throws that exception or not. Mhm. The moment we give that readable, non-readable channel, so the moment we give that true, it doesn't like it. So it has to be a readable channel, probably. Let's see. Yeah, the moment we say false and try lock, let's see how it's going to be here. Oh, did it go there actually? My debug point is waiting on that thread probably. Yeah. Okay, so let's see what it is doing here. Yeah, it got the lock. It's waiting, and the second one is also waiting in here. Yeah, it threw the same exception. Yeah. So to get a shared lock, probably we just have to read it. We cannot. Yeah, mutually exclusive lock is only for write. And how can we do a read write lock, right? Okay, I can put on top of it probably random access. Okay, random access equals to new random access and the name of the file and mode, right? We just want to give the name of the file and a mode. So, okay. Uh, but the thing is, we will not be able to get the channel out of it, right? Let's see. Um, I have a file object in here, file test file equals to new file. So what are we trying to do here? File of output stream is not defined. Yeah, it's all input stream. Then it doesn't make sense, right, for you. Okay, okay, I can do something like this. Input stream I stream file input stream of the name of the file that you're talking about, and then I can make this guy as a file. uh, I can just do this probably. Yeah, then you cannot get a handle of channel. What am I talking about? Yeah, so you can get a file, but that doesn't help, right? um, you can open it for read write, okay, but how do you get a stream out of it, right? Channel of that file. Yeah, you can still get a channel. Good, you can still get a channel, and now it is open for both reading and writing, right? So let's see how this works. Yeah. mm, okay, so here is the thing. So what are we trying to do here? We're trying to attain a random access, and then we are reading it, and I'm going to get a read lock, shared lock here, because we opened the channel for both read and write. Okay, so that way it should not complain about it. Right? Let's see. Okay, so let's go to this run method, and here we are actually reading the file. Okay, and we open the channel, and we said lock, so it's a shared lock now. Each shared is true. It executed, like sleep is executing on that. And let's go to the other thread, and it has to create another thread. Yeah, so let's go here. The other thread came in. Yeah, still it is throwing that overlapping exception because it is open for both read and write. Shared lock, right? Probably I should be reading only. Then it will work, probably. Yeah, it will not let two people write at the same time. That is for sure. But yeah, let me see here. If I'm opening it only for read, yeah, that doesn't help either here. It threw the same exception. That means, mm, yeah, we cannot let two people get the lock at the same time, looks like it, though it is shared, right? But now I opened only for reading. Let's see what happens. Okay, so now this guy is in here. Okay, so it is open only for reading. So we are good. Got the lock. Yeah, this thread is sleeping in there. Then we went in here. Second one is again open for read. Even two people reading it doesn't let it. This doesn't make sense to me. Overlapping. What are we overlapping on? You know what? It could just be the compilation thing. Or do I have? Yeah, it could just be compilation thing also. I'm not sure. Well, let's see. Okay, let me actually do this one. Okay, it could just be that. Let's see. Even the previous one would have worked. We don't know, right? Let's see. Okay, we got the thread. First one is going in fine, no issues. Just waiting in there. We got the next thread. Yeah, still the same. Yeah, doesn't look like, though it says shared, it's not letting us open it. Hmm, yeah, interesting thing to explore on. Probably I'll try a little bit later and tell you guys. But the thing is, right now, the concept that I wanted to show was, okay, if you lock, we are not letting anybody else to do something. And we could demonstrate that. But all I tried in past 10-15 minutes was to actually make it like, okay, shared lock and let multiple people try editing it. So once we get the lock, looks like we are not letting it um, we are not letting anybody else to actually share it, though we say shared lock. It says like still overlapping exception, overlap file lock exception. And when do we get an overlap file lock exception? Let's take a look one more time before we say anything. Now, if the locks that overlap the requested region is already held by this Java virtual machine, or if another thread is already blocked in this method and it is attempting to lock an overlapping region of the same file. Yeah, so it's true, right? So they did not guarantee that. Okay, if shared lock is true, what's going to happen? Did they say in here somewhere? Yeah, some operating systems do not support shared locks, in which case a request for a shared lock is automatically converted into a request for an exclusive lock. Maybe Mac is one of those Do you guys want to try the same program on Windows? Probably. Like, um, though it says shared lock is false, maybe it is converting internally into exclusive lock. Maybe you guys want to try false to request, and yeah, maybe you guys want to try that part. Let me actually see. If I say channel, right, lock, yeah, no, it doesn't make sense. Yeah, maybe try it out on Windows, and if you see a different behavior, let me know actually. But the thing is, right now, files, yeah, it's not allowing us to put shared lock. I'll explore a little bit more, like how can we put shared lock. But for now, understand it like okay, locks help you in locking any other read operations by another Java program in the same JVM. Okay, that's the takeaway. Any questions?
No.
Yeah. Okay. Actually, I wanted to start threads as well, but probably I'll start tomorrow. Okay. So this is one of the ways I created a thread is by implementing the runnable interface. Okay. Threads can be created by either extending a thread class or implementing a runnable interface. When you implement a runnable interface, you got to override this method public void run. So as I have already written, I just want to share that. We'll talk about threads tomorrow from scratch. Like this will be the presentation for that. But if you have any questions on files, like did you understand when do we use file output stream, file input stream, object output stream, object input stream, and nobody asked me about locks so far, but I just wanted to show. So if you are thorough on how to write to a file, read to a file, how to do manipulate data by using buffered input stream, buffered output stream, data input stream, data output stream, and closing the stuff, flushing the data, and stuff like that, I think you're good. Nobody is going to ask more than that. Okay, follow through all the examples that we have, and I think you should be okay. Mm, Let me know if you have any other questions. I'll explore on this part, like how to attain a shared lock on a file when it is open for both reading and writing. That is like an interesting area for me as well. Let me actually explore it, and if I can come up with something, I'll share with you probably in a day or next week. Okay. Anything, any questions, still stuff that